Hey guys, welcome to day, 48 of Codeforces Everyday until GM. Today just gonna be a short little video. I have to go in like an hour maybe. So, we might not do a 1200 today. Usually, as y'all know, I start off with a 1200 and then if I have enough time, I'll do another 1200 or else I'll wrap it up with some 1000 rated. We might just like knock out some 1000 rated today. Just because time. Um, And some of these can be like pretty difficult and take a little while, but hopefully we spend under like 30 minutes for keep them within like the 15-30 minute range would be really good because then we can do a few of them. But we'll see. I'm gonna cap this video at like maybe like 45 to an hour just so I have enough time to get where I need to be. But yeah, without further ado, let's jump straight into it. Gold Rush is interesting question. Where did I put my glasses? It's on my bed over there. I'll get them later. 1000 rated. Okay. Initially, you have a single pile with N gold nuggets. In an operation, you can do the following. Take any pile and split it into two piles so that one of the resulting piles has exactly twice as many gold nuggets as the other. Okay. One possible move is to take pile size 6, split it into... Okay, got it. Can you make pile with exactly M gold nuggets using 0 or more operations? Okay, so let's take in our input, t equals int input for underscore in range t. We take, oh my god, we take in two integers, n and m, equals map int input split, and then what? For each print yes if you can make a pile exact size m, no otherwise. You can output the answer. Okay, so given our in piles, take any pile and split it into two piles so that the resulting has twice as many as the other. So given this middle pile, is to take pile of size 6, split it, take any pile, split it into two piles. I don't really get it, actually. Okay, 6-4. The first test case is pictured in the statement. We can make a pile size. Okay, second test case we can perform 9-4. 9 is 6 and 3, and then... Oh, I see what it wants us to do. So... N is the starting pile size. So, okay, so if I'm thinking of this correctly, N is, let's get some room, is how much we start with. So in this case, we start with 9. How am I drawing these? We have these things. 2, 3, 4, 5, 6, 7, 8, 9. I have an extra. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, okay. So we got our 9 starting, and then we can split it into 6 and 3. And then we can split this into 4 and 2. So the split will always be... let me think. It would be divided by 3, and then it's like 2/3, 1/3, right? And one pile would be 1/3, the other pile would be 2/3. And then we see if we can make N M. So how do we go about this actually? We want to see if we can make 4. We will always only have one possible split, right? 2/3, 1/3. Check. If not, then we have to choose which pile to split. Okay, so DFS similar, DP brute force. I do understand how we can use DP. So okay, we start with 9. Right? We can split this into 6 and 3. And then since we don't have it, we keep splitting. How do we know which one to choose? Since this side is less than M, we can discard this side. Now 6 can be split into 4 and 2. And we have it, so return. Now what if we have a split where both sides is greater? I'm sure they have a test case here. This is impossible. 27 and 4. 27 can be split into 27 divided by 3 is 9, so 18 and 9. We've already seen 9 before. Since we've seen 9 before, it just returns yes. Ah, that's cool. How do I do this? Equals 4. Well, it really depends on M, right? If it's like any other number. Okay, I think you would have to store like each split, right? And then if it's not possible to split it, you store -1. So we should create a DP array outside of everything. and like dp0 is -1, dp1 is what's our max size? 10 to the 7? dp1 is okay, do we create the DP array first and then look up, or do we build it as we go? That's the real question we're asking here. Okay, first I want to like create a recursive implementation, and then maybe there will be ways to make it faster. But like the logic is pretty simply just 1/3, 2/3, right? And if it's not, drop. So def solve. And we take in a number in L equals n times 2. Wait, we check if it's divisible by 3 first. If n mod 3 does not equal to 0, return -1. L equals n times 2 divided by 3. R equals n divided by 3. Okay. If n equals -1, wait a minute. Let me think. Let me think this through. We check if it's possible. We discard branches we don't need. So let me think. So what's our base case? If n, we've taken n m. If n equals m, return n. If n mod 3 is not equal to 0, return -1. How about left and right? There's one more case here. It's if n is less than m and we should return true, return false, and then return solve L or solve R, right? I think this works. That's with 27. I think so. So I think I can print solve. Oh. True. Okay, this isn't right still. Yeah, what's going on with this case? 4-2. Four mod 3 does not equal 0, so it should return false. So why am I printing yes? Oh, I should be using or here, I believe. Okay. Yeah, now I need to make this. How can I use DP to make this faster? Create a DP array, and we can pass in DP. Type in DP. Everything should be mostly the same, except we can add a check here, like if in DP, then we just return DP. And then we would store this DP in equals this, and then we would return DP in. Drover. Oh, let's DP. Index up. Okay. Means we have to set aside. Let's just make it a dictionary. That works. Do we just try it? It's probably a way to make this faster. I might need to make this iterative instead of using recursion, because I know Python has a recursion limit. It worked though, so I'll take it. It is. Do we have enough time? How long did it take me? 23 minutes? Do one more question? Why did I close my Excalidraw? Maximum cost permutation. A permutation of length n is a sequence of length n such that each integer 1 to n appears exactly once. So let's define the cost of a permutation as the minimum length of its contiguous subsegment that needs to be sorted so that the entire permutation becomes sorted in ascending order. You're given an integer array P consisting of integers 0 to n, where no positive integer appears more than once. You should replace zeros with integers so that the array P becomes a permutation. Your task is to calculate the maximum possible cost of the resulting permutation. Okay, first line, take an input in P and then list. Okay. Print an integer the maximum possible cost of resulting permutation. Recall that a permutation of n is a sequence such that each integer from 1 to n appears in it exactly once, okay? I know what a permutation of n is. Let's define the cost of the minimum length of its contiguous subsegments next to each other, right? That needs to be sorted so that the entire thing is sorted. The maximum possible cost of the... You're given an integer... No pause. Replace zeros with integers so that P becomes a per... Okay, so... You can take permutation with the cost of 3 because you need to sort 2, 4. Okay. Make a permutation with the cost of 3. Maximum possible cost. Okay. Okay. I understand, I think. So... I think that the numbers we are allowed to put are kind of forced. Like, I think we can just make it the first zero, the last zero minus the first zero. That's our maximum. And then we need a sort. So I'm thinking we just... Do we just sort it and count the differences? Or like... Something like... We take out the zeros, sort it, put the zeros... Wait, no. Something about the zeros. Because sometimes the zeros just... are forced. Like this is forced to be 4, this is forced to be 1, this is forced to be... No, these are not forced. These can be anything, but like... Huh. Mm. Permutation... Maximize the thread cost. Okay, how do we... Let's define the cost. It's the length of its... that needs to be sorted so that the entire permutation becomes sorted in ascending order. So it's like if we have 1, 2, 3, 4, 5, the sorted version, we want something like 5, 4, 3, 2, 1. Because 5 of them are not in the right spots, right? We can also have 2, 1, 2, 3, 4. So always this will have 5 as well, right? Okay. So it's. I mean, if this was a 3, I guess that's still in the. Okay, so isn't it just to calculate the cost equals last minus first? Like last wrong minus first wrong? To maximize this, we want to basically, given the chance, like the middle doesn't matter. We just want to force the sides to be wrong, which is like give it our biggest possible value and our smallest possible value. Right, so given the length of array n, so n is our max possible value, which means 1 is our smallest possible value. And then we so we need to find the max of an array, of the array. And then we need to find the what's the opposite of max? we could just search. Smallest exclusion. S equals set R equals 1 while I in R plus equals 1, return I, and then this one's like the same thing, except we iterate backwards, right? We don't need a while loop. We can use a for loop for I in range max R go to 0, then we increment backwards from 1, and then if I not in R S return I. Something like this, and then do I even need to do this? If I only care about first wrong and last wrong, I don't think I need to do this. I'm making this so complicated for no reason. It should just be LR equals 0 n minus 1 while L is less than R. Sorted P equals sorted P. I don't think I need this at all, actually. If P, L, oh. Oh no, we can't do that. We have to sort P and then put the zeros back. sort P, and then put the zeros back. I'm gonna close my door real quick. Be right back. I'm a little bit stuck here. I think this works. We gotta store the positions of the zeros, right? Well, we can create a like we have to store the numbers that it's been used, and then we have to store the positions of the zeros. We have to fill them out, and then we look for the first incorrect and last incorrect, and then we compute the cost. I think that's it. Right, so we can then used equals for I in range in pi minus equals 1 if pi equals -1, then it's a 0. Pause zeros dot append I, else we use this number pi equals 1. Okay, so basically what we're doing is we have this array stores the indexes of the zeros. This array is like a truth table for the used numbers. And what we're doing here is just zero indexing the array. And this for loop just basically fills out these arrays. Now we need to check if len zeros, if it's only 1 0, then track an unused 0 for I in range in if used I equals 0, unused equals I. P pause or P0 0 equals unused. And then we look for the left and right indexes. So L equals 0, R equals N minus 1, and then while left is less than N, and P L equal to L plus equals 1, while species out R is greater than 0, and PR is equal to R minus equals 1. And then finally we print the max of 0 and R minus L plus 1, I think. Okay. Yeah. This is check the 0 case. This is to check for first and last mistake. This question was low-key hard. I'm gonna bookmark it. Alright, let's see if it works. So I gotta get going. Please don't give me a TLE or something. That'd be sad. Alright, we got it. If y'all enjoyed this video, be sure to like and subscribe. I will see y'all guys tomorrow. Bye.